So one of the things I'm actually going to be looking at is agricultural land. So this is a great time slot for combining what Jesse was just mentioning. And we're going to look at ways that we can take the brilliance of the beaver and implement it on parts of the land that beaver wouldn't normally colonize. So in the beaver dam process, they basically do things to slow spread, sink, soak, and store water into the land, but they usually only do that where the water is. So if we take those practices and do things like contour farming and contour orchards or contour forest management, we can get the same benefits you get in the stream, but we can get them all the way to the tops of the hills. And by doing so, we can turn flooding liabilities into agricultural abundance and groundwater recharge. So we're going to talk about the brilliance of the beaver. And I'm just going to go through some real simple stuff, and I'm going to go through this stuff kind of quickly because I think the beginning concepts are real simple, but it's to bring in some context. Well, we get rain, and typically we get more rain in the east and less rain in the west. And when the rain comes, we can't just turn the rain off. So if you can slow it down when you get it, especially in more of the western environments, if you can slow that water down, it becomes the water is life asset. So as I said earlier, more water in the east, less water in the west. Sometimes we get entirely too much water when something like Hurricane Ida comes and brings massive flooding to Louisiana, but then continues and basically takes a flooding spell all the way up the East Coast, almost to Canada. And that's nothing new. These are the hurricane tracks from 1949. These storms are going to come. It's not a matter of if, it is a matter of when. But at the same time, there's other parts of our country that are in massive drought. I want to highlight that drought and flood are really two sides of the same coin. We can solve both problems by using nature-based solutions, and the people in this room probably know more about it than most people on the planet. I want to talk about something that Bob said earlier. You know, all of these natural disasters cost the United States billions of dollars annually, and much of this cost is picked up by the United States taxpayer. Because of that, the government is quite interested in doing things that can mitigate the intensity and the cost of some of these natural disasters. And the cost of these is going up every single year. This is a chart of the different disasters, whether it be flood or wildfire or drought. The cost is and has been going up since 1980. Now this is a little bit sensitive, but I want to highlight here the one in red. That's the cost of 9/11 in financial terms, not in the terms of human life. $27 billion. The chart that we just showed demonstrates that every year we have natural disaster catastrophe greater than 9/11, but it's not getting the same level of concern. And I think we have a little bit of a marketing issue here. So we can demonstrate that there are a national level crisis going on every single year that we've just become accustomed to. How do we solve this problem? Again, marketing. We have sort of a real simple concept here. When a raindrop falls out of the sky and lands on any patch of earth, whether it's a beautiful wetland or a grassland or a farmland or a parking lot, that drop can only go three places. I typically try to engage the audience and say, where can that drop go? So go for it. Where can that drop go when it comes out of the sky at 27,154 gallons? It goes up. He says it can evaporate away. Where else can it go? It can go down. It can infiltrate into the ground. Where else can it go? And it can run off. So we all got it. There's only three places it can go. And it's our land management and our land stewardship that affects how that raindrop goes. Everybody understands this, right? Because you can see it. Rainfall enters the rivers and it runs off. When it infiltrates, a lot fewer people understand the groundwater system because we just don't see it. So getting back to that question that I think Chris asked earlier about where is the storage, eventually if that water soaks below the depth of a plant's roots or a tree root, it enters some sort of groundwater system depending on your geology. And there's different types of ways that we manage the land to affect which direction that water goes. So everybody knows as you start developing more and more land and put more houses and more impervious surfaces, the amount of runoff increases, the amount of infiltration goes down. But they don't really think about it too much on a broader scale. So here's how America uses its land. I also want to highlight any title that's in quotes up here. If it's in quotes, you can Google that exact term and you'll come up with the document where you can see this case study for yourself. So here's how America uses its land. You can see the area in Illinois is a lot of farmland. And then over here where Skip is at, you have much more forested land, and so forth. But the thing that I think is really interesting is they break this down. They break this down and they put all the like parts together. So about 35% of our country is under grazing, about 28% is under forestry, about 20% is under crops. So if we want to change watersheds, we can't just be looking in the urban areas. Urban areas only account for about 4% of our landscapes. Most of our watersheds are under these grazing types. So I asked a question similar to what Skip was bringing up earlier. Ancient, if we go back in time, what managed these landscapes in more ancient times, before, say, 1492? Well, and then how can teaming with nature benefit us today? How can we mitigate risks in each land use? So because 35% of the USA is under pasture, we can do bison biomimicry. In the forested lands, we can do beaver biomimicry. And then on a lot of our croplands, there's different practices, basically the principles, the 6 principles of soil health to help manage our croplands. Again, bison manage the uplands. Unfortunately, the bison were hunted to near extinction between 1820s and 1880s, and their population fell from over 30 million bison to down to just 1,000 individuals total. I want to bring up a point that Hillary made the first thing this morning, and that is the bison were never fenced out of our creeks, so it's not that they just can't have access to the creek, it's a matter of time. When the herds went through, they would hit the creek, they would hit it one day, and then they'd move and they'd be gone. So short-term duration and impact is not a problem. It's the longer term constantly being at the creek where you start getting damage. And then we have our friend, and I think this is the only slide I have actually about beaver, even though I'm at a beaver conference, but you guys know more about beaver than I do. I'm just trying to talk about how we can take the brilliance of the beaver and take it to different places where we might not normally see them. So beaver managed nearly every watershed in North America, but they were also hunted to near extinction by the 1850s, and a similar thing happened in Europe. And then I won't go into, I want to elaborate on this further. There's a couple of excellent presentations by Ben Goldfarb that go into the natural history of the beaver. But I will talk about land management. So bad land management, to include the removal of keystone species, often leads to degradation over time. And that degradation leads to loss of biodiversity, climate change, and loss of livelihoods. But we can also do ecosystem restoration. We can do things like slowing, spreading, sinking, soaking, and storing the water. We can bring life back to our forests and our grasslands. We can also reestablish some of those keystone species that are so important to how our land works. And I'm going to bring a couple of examples actually on the farm side, and then I'm going to get to the beaver side. So if you look up banking on soil health, you'll find out that the average farm that focuses on soil health increases their yield by 12%, makes 176% ROI, and they have increased infiltration that reduces water runoff. They get less soil erosion, so they're basically making our waterways more habitable for things like beaver. That also leads to improved water quality outcomes. So there are examples where we can improve water quality and do it at enhanced agricultural profit. I was at this farm about 2 weeks ago. It's in Texas. They were using bison biomimicry to turn areas that were massively degraded into healthy grasslands, and they moved a herd of cows, 5,000 cows at a time, 5,000 to 6,500 cows at a time, and they moved them every single day. So they were mimicking the bison. One big herd moved every day, and sometimes it might be 6 months before the cows go back to that same pasture, so there's plenty of time for recovery. What you get then is you let the grasses grow high, and as the grasses grow high, the roots grow deep. And we all suffer from this type of ecological amnesia. We don't understand what our country looked like when it was managed by bison. We don't understand what our rivers look like when they were managed by beaver. And it's really the climate of the mind. And that's the hardest environment to change. So how much better would our waterways be if they were allowed, if all of our land was allowed to mimic a native prairie, or it had a beaver on the landscape again, or bison? There's examples around the world where we're mitigating deserts. We're literally turning deserts back into grasslands at enhanced agricultural profit. And which of those parcels of land do you think is going to make more money? Which one do you think is going to have more runoff? Which one do you think is going to lead to better waterways? And a lot of that's because the native roots run deep. So those roots are actually building the soil structure, building the ability for the soil to soak that water up and store it in places besides just the creeks. But you have to let the grasses grow. We've known for a really long time that if you're constantly grazing them short or mowing them short, the roots just don't grow. You have to let the grass get to, or the plants get to a large size before their roots grow deep. But then if you come back and graze them, the roots shear off. But they don't just like pull their roots out of the ground. All that root mass stays down there, and it stays the organic matter that our soil needs to become a better sponge. And that allows you to really soak the water up. And a lot of times we don't really see the hidden half of nature, sort of like the recharge. We don't see underground. So we miss out on literally half of the amazing attributes of life that are just right below the surface. There's an excellent book by David Montgomery called The Hidden Half of Nature. He also wrote a fantastic book called Dirt, The Erosion of Civilizations. I highly recommend both. On farmland, I just totally recommend Gabe Brown TED Talk. He's talking about on ways if you treat your land and you keep it covered, right? Because in nature, you almost always see covered land. You don't see bare soil. And by covering your soil and mimicking a prairie, using biomimicry, you can keep that soil and that water on the land where it's an asset, instead of the soil and the sediments being in our rivers and our streams and our Gulf of Mexico, or your local water body, the Atlantic Ocean, where it's definitely an asset. You can see this in great detail if you just Google rainfall simulators. So in nature, how often do you see bare exposed soil? How often do you see bare soil in agriculture? We often try to simplify nature and make it easier for our human minds to understand. We definitely do not understand the unintended consequences of many of our actions, like taking all the vegetation off of the ground and leaving bare soil for months out of the year, or straightening rivers. And sometimes we do things like plow straight up and down the hill. So what happens when you plow straight up down the hill and the water leaves? You get this massive erosion. We're losing two of our most important assets, right? Plants need four things to survive and thrive. They need sunlight, they need carbon dioxide, they need soil, and they need water. But the sunlight comes up every morning, it's not limiting, and there's plenty of carbon dioxide in the atmosphere, that's not limiting. So the two things that plants really need are soil and their water. So why are we engineering systems to wash those two things into our rivers as fast as possible? It's kind of silly, right? And what happens when too many gallons leave too many acres too quickly? You get infrastructure damage. This is costing, again, billions and billions of dollars every single year. This is a flood in Texas in 2015. Does anybody have any idea how much one of those bridge segment weighs? It weighs a lot. Do you know how much force it took to take a bridge segment that weighs a lot and push it, 300, 600 feet downstream? A lot. Okay, do you think a beaver could make a dam across something like that? Hell no. So how do you fix that? Also, when that soil and water leaves, you can see it. There's the muddy brown runoff, and here's the crystal clear spring flow. And I think we need a lot more of that and a lot less of this. What else is with that soil when it washes off our land? Nutrients. What do nutrients cause? Algae. So even though this guy looks like he loves the algae bloom, really algae is a huge problem, especially if you're in and around the Great Lakes or places like Toledo, or really anywhere, the Gulf of Mexico, where you have the dead zone the size of New Jersey. So how do we solve that? So here we are after 30 slides or whatever, getting into the brilliance of the beaver. We got to leave something on the ground, even if it's just little pieces of mulch. You can walk out into your landscape and see these little microdetritus berms. You'll find them everywhere after a rain. I don't care what environment you're in. If there's any sort of structure left on the ground at all, you're going to find this pattern. One of my neighbors did it in his backyard, and he just laid out his flower beds on contour. So that's a little swale. There's the little beaver dam out of mulch. and what you get is that green spot. He's not out there watering the alley. He just took a picture over the fence. If you Google swale plume, there's an amazing 98-second video showing how when you catch that water and soak it into the ground, it plumes out and creates basically subterranean gravity-powered irrigation of the landscape. Well, beavers do that too, but instead of making microdetritus berms, they make megadetritus berms, and they really do a great job at slowing the water down. But unfortunately, in our brilliance, in our human brilliance, we decided that it's okay to take like a couple 100 million beaver, we can remove several 100 million beaver out of our landscape and it's going to be all right. Just like several people decide they can take all of the trees off their land. So this is a gentleman I always try to highlight in my talks. His name's David Bamberger. If you search water from stone, you'll find a presentation, a little video he did, where he was trying to restore land in the hill country, but he bulldozed and burned all of his trees. Then he's like, oh crap, I need to slow the water down. So what's he using? He's now using stones. So he's laying stones on contour to slow, spread, sink, soak, and store water in the landscape. So I saw him in 1992 when I was in the Boy Scouts, and was like, oh, I can do that. So when I was in high school, I went out and I laid down brush. I was trying to think like a beaver, even though growing up in Texas, I only saw one beaver in my entire life until well into adulthood, and that was in Colorado. I just never thought like a beaver because we never had them. I knew about them. What I realized is as water tries to go down your hill, this will help filter out leaves and debris and sticks and all sorts of stuff, but the water still leaves, and I wanted to keep the water to stay because in Texas, we need that water. So I decided if you cover it with mulch, you can basically clog your brush beaver biomimicry filter and keep that water and the soil on your landscape. This is following an ancient German technique called Hugelkulture. So in Hugelkulture, if there was a windstorm or something and there was a lot of downed trees, they'd lay the downed trees, they'd cover them up with dirt, and they'd plant things on it, basically letting the carbon bonds in the trunk of that tree, that solar-powered battery, release its energy slowly to power the next generation of growth. So something that starts out as a little apple tree, he starts digging down and mining the carbon within those logs until all of the carbon slowly, the energy, the stored solar power is used to repower that next generation of life. And started doing this over a larger and larger scale. This is a Honda Accord for scale. That little blue dot is a Honda Accord. Here's an erosive creek. The water's going that way. And we did brush clearing, paid for by the state of Texas, because in Texas, brush is awful, and we want to get rid of as much of it as we can. So we're cutting down trees, but we're laying those trees out on a keyline pattern, so you can see the brown lines. So as the creek goes that way, imagine the veins of a leaf. And so as the water tries to leave, we're siphoning a little bit off, and we're slowing it, we're spreading it, we're sinking it out into larger and larger areas of the leaf landscape. And I was doing this on all sorts of land, wherever I could. I was trying to think like a beaver because I didn't know anything about beavers, so I was learning at a very young age how beaver worked through trial and error. I also did a lot of work with FEMA after various storms like Hurricane Michael that knocked down 78 million trees over 3 million acres. And every one of you knows what happens after a storm. You've got lots of mulch, lots of downed woody debris. So how can we use that mulch? How can we think like a beaver? And how can we turn a row of mulch into a water harvesting structure that turns into wildflowers? This is in 2015, the same year that those bridges blew out, and this property was losing 0 gallons of water. And it started turning it into wildflowers. So the same road, a spring and a year or two later, covered in wildflowers, covered in pollinator habitat, helping slow the water down. Just like the fence line comparison, we've got one side of the road and the other side of the road. Pretty much the same. It might not have been the exact same day, but it was the same time. This is the climate of the mind. This is your land management. You can decide to make your land healthier, and doing things like bringing back these ecosystem functions really will help with that. The same time I was doing all of that, that's actually my front yard. That's my roadside. That's the entryway to my property. I was working for the Department of Defense, and we were doing a project on a little bit bigger of a scale. So this is a runway, just for a size comparison. We did a brush clearing project over 2,800 acres of land, and we did it in 3 different models. One was a bulldoze and burn in pink. One was a bring a forestry mulcher in and just mulch down any tree that's in your way, or really these juniper trees that we think are awful, and but they're not. So we'd mulch it in place, and then we would do my beaver biomimicry. I literally had to jump up and down and like pound on the table and fight with my boss to say, you just hired me to protect the natural resources of the military. Bulldozing and burning 2,800 acres of trees ain't that, So we've got to do a better way, and they finally relented because I was extremely persistent. So look at level contours. These are LiDAR lines, so those are perfectly level lines. This is the brush that's about 18 feet wide and about 18 inches deep of nothing but mulch on contour all the way up to the hilltops. So as the water tries to leave the hilltop, it gets caught by this like flood speed bump, and you slow it, you spread it, you sink it, you soak it, and you store it into landscape. And this particular project done in 2010 has had no runoff. It caught 11 and a half inches of rain in a 24-hour period, Memorial Day 2013. It caught 18 and a half inches of rain in 2015, Memorial Day 2015, same time those bridges were washing out. Again, no runoff. 18 and a half inches of rain in 2 weeks. No runoff. Brought springs back to life that had never been documented before, and they flowed for 4.5 weeks after some of those rains. The military was actually getting pissed because some of these springs were flowing down the lowest part of the landscape, which was the highly eroded roads. So we had roads they had to close down after the rains. But again, you're catching a flooding liability. They also, at the military base, they had cars that got washed off the road in flash floods, and people died. So we literally took a deadly flash flooding liability and turned it into more groundwater recharge than the base could use on an average annual basis. So we're turning flooding liabilities into groundwater assets, and we can do it on farmland and forest land and ranch land at enhanced agricultural profit. So here's what they look like. The troops actually use these as driving roads. You can see some little trails on there because it's less rocky than the surrounding land. This is steep, this is rocky, and slowing the water down, they were finding that close to the mulch on both sides, we had a 300% increase in plant productivity. So if you're on a farm, that probably yields 300% more grass, which yields 300% more beef, which pretty much equates generally to 300% more profit in your pocket. And most ranchers just burn it. They're putting the carbon back in the atmosphere where we already have enough, and we're keeping it from getting into our soil where there's a distinct lack of carbon. I want to highlight that when Bison managed our prairies, we typically had 8 to 10% organic matter. We could absorb 8 to 10 inches per hour of infiltration. Now the average farm and ranch has less than 2% organic matter, could absorb less than 2 inches per hour, and we wonder why there's massive flooding. We can regenerate those lands, and there's places across the country. I suggest Gabe Brown TED Talk. Emily said something earlier that you cannot really fix the hillsides with beaver, and that's totally true. But we can fix the hillsides after wildfire if we use the brilliance of the beaver. So we can go into a spot that got damaged by wildfire. We can use a little laser level and map out a line on contour, use some of the dead stumps and grind the rest up into mulch. We're basically making a little micro beaver dam. And the greenest place on the landscape, right, because you're keeping the soil and the water, the greenest place on the landscape becomes those little berms. So you're starting the land regeneration process from the beginning. And there's cost share from this. The NRCS has tons of cost share programs. There's a program right now, they're seeking out historically underserved farmers. Young farmers qualify for that. Here's a farm in Texas, went from bare rocky hillside to terraces, and all paid for by a USDA grant. This farm won a Green Infrastructure Award from the Environmental Protection Agency. Basically, we're creating the little, the little canals and ditches that the beaver dig from their ponds. We're sort of replicating that on the landscape. Just 1 year later, covered in wildflowers. He planted fruit trees, so we're turning a flooding liability into pollinator habitat and food forests. Again, another property got a young farmer grant to do basically contour terraces. If you look at these terraces, all of the water stored below grade. Again, it's like those canals that the beaver dug. So all of the water stored below grade. You can see a spillway, a spillway, a spillway, a spillway, a spillway. The spillways are still green. We did not dig there at all. I'll go back one slide real quick. The water is stored underground in this area. The pond, the dirt that we pulled out is not actually, that's like the beaver dam. Water doesn't pack up against the beaver dam. It only is stored below ground. And I'll show you why we zigzag this. So the water, again, stored in the swale part. That's like the ditches that the beavers dig. When they overflow, overflowing water hits standing water. Has to come all the way here over here. Overflowing water hits standing water. You don't want to line those spillways up in a row because there is a possibility you can have water just flow straight down your system. So you always want to zigzag it. Sort of like bricks in a house. You always want the bricks. You don't want to see straight lines, vertical lines in a house. That's a weak spot in your bricks. First big rain after digging, and a year later, totally covered again with vegetation, turning a flooding liability into fruit trees. So we can think like a beaver, but instead of going and cutting the trees down, we can use that water to plant more trees in places where the context serves correctly. Same people doing the same work on the same land just won an award, another green infrastructure award in 2021 for the city of Austin. And this nature-based green infrastructure project just won the 2021 EPA Green Infrastructure Award. It is on endangered species habitat. They're increasing biodiversity. They're enhancing endangered species habitat. They're regenerating native pollinator habitat while capturing floodwaters and sequestering carbon. The Beaver Biomimicry Project helped protect Barton Springs, that the mayor calls the crown jewel of Austin. And if you think about springs, whether it's in Florida or Missouri or anywhere around the planet, typically those springs are still some of the economic engines that run those communities. It's why many of those communities were there, because of the groundwater asset. And if you look at this, I love this book, Brad Lancaster, Water Harvesting for Drylands and Beyond. It's showing where the water goes. It's infiltrating down, but on a larger scale, you can see that as these beaver dams on contour, so basically whether it's the trees or those little swales, you catch the water when it rains, you soak it in, and those are the swale plumes, just like we saw in my neighbor's alleyway. But those swale plumes plume that water down through the landscape, make more green for grass, make more green for cows, make more green in the landowner's pocketbook. Again, turning flooding liabilities into groundwater assets at enhanced agricultural profit. You can do it with contour agroforestry. But if you notice, the lines aren't straight and parallel. So this is something that Scott mentioned to me earlier. And these are my last two slides, I think. The water droplet is kind of dumb. It's that physical process. I want to get to the bottom of the hill as fast as possible. You do that by going straight down the hill or perpendicular to the contour lines. So the water droplets all just go into the valleys. But if you use keyline design, it's a whole other topic. I could talk about it for hours, so I won't. I'll just say keyline design keeps your rows straight. You can regenerate your soil by using keyline design and a little bit of disturbance. And you have contour perennial polyculture orchards. This one happens to be in Wisconsin. And if you look, the rows are nice and straight, so you can drive a tractor down and drive the tractor back. You want to keep those rows at least twice the width of your widest implement, so you can drive back and drive down and drive back. This is nothing new. Here's in Ohio. They've been building these types of beaver biomimicry systems for thousands of years. This one happens to be Fort Ancient Earthworks in Ohio. This system has 131 ponds. It's 2,000 years old. It's still functioning today after 1,800 years of total human neglect. So these are the kind of things we can invest in. If we have a once-in-a-generation investment, we can invest in things that are going to last a long, long time instead of a bridge that might last for 20 years before it gets blown out by another flood. And they've been doing it around the world. This is the Lessons of the Los Plateau. They did these types of things on very steep hillsides. I wouldn't really recommend doing it on land this steep. However, within about 20 years, they turned a desert into a productive forest and agricultural ecosystem, and they brought tons of people out of poverty. So again, the climate of the mind, we can change it. We need to get over this ecological amnesia, and we need to do things that help use the brilliance of the beaver to slow spread, sink, soak, and store water in the environment. I thank you guys so much for being here. You guys are really leading the charge for nature-based resilience. And I'm going to actually have another presentation tomorrow that goes into great detail on where the federal dollars are and how we can learn the language that we need to access grant funding. The grant funding is there. There's billions of dollars available every single year. So if you want to learn a little bit more specifics on how we can take some of those grant dollars and put them towards the kind of projects you want, I will gladly help you work on your messaging and your wording and your jargon to help you communicate more effectively with the different agencies that have their own different jargon, but they want to focus on nature-based solutions. Thank you so much.
Actually, you have time for one question. So if anyone would like to ask a question.
Oh, come on. There you go.
All right.
Hi, I'm. Oh wow, it's so loud. I'm with the Animal Welfare Institute, and we're working on a grant program to help with much like there is with wolves in western states, a program to help with ranchers that might lose their livestock to wolves. We're kind of working on a similar thing to help mitigate damages that beavers might cause. So I just wanted to say I'd like to get your kind of opinion on that kind of grant program or project, if that's something that's you would know maybe how to work something like that better.
Yes, there's a excellent. Let's see. Well, anyway, I'm gonna cheat. Here we go. The regional RCPP, Regional Conservation Partnership Program, $300 million every single year to go to projects very similar to these nature-based solutions. They've already funded a project with the Audubon Society. They're doing. They spent about $3.5 million to help convert 2.3 million acres of land into bison biomimicry that mimics the way the bison manage the landscape. They're mainly doing it to create bird habitat, grasslands, and what they call bird-friendly beef that Audubon actually helps the community helps the farmers sell and get a premium price for their bird-friendly beef. But at the same time, as they generate all those lands, we have 2.3 million acres of healthier land now. They're not using wolves, they're using hot wires, so they're moving those land every day. There's also, we were talking earlier about the radio collars on Beaver. They actually have these new things that are virtual fencing collars. So you can put collars on the livestock where you can literally draw on your iPad where you want those cows to be, and they'll go there. And if they step out of those bounds, they get buzzed or they get beeped. And then if you stepped out of those bounds, they get buzzed. And if they step too far out of those bounds, they get shocked. So that helps keep them herded. It becomes the virtual wolf. It becomes the virtual predator so that we can get those, the benefits, the bison biomimicry benefits of keeping the animals herded. Was that onto your question? Because there's funding for that, but I think it's going to be a hard sell to get funding for reintroducing wolves. That seems to be that's just one of those mental hurdles that many people in our government aren't ready to jump over.
No, yeah, definitely. I just agree. So that's perfect. Thank you.
Thanks.
All right, thank you, Bryan, and thank you all.